So give a big welcome of applause to our next speaker, Andrii. Can you hear me? Everything clear? Cool. So I'm happy to see everyone. For the start, raise your hand who had experience writing or maintaining a chat system. So some people, maybe 20%. That's great. Today I'm gonna share our own experience of writing Messenger. We will go through the story, why we need, and the key points in our journal for the full-fledged instant messenger. My name is Andrii. I'm working as a lead Android engineer at Lalafall. It's a C2C marketplace. And 1 year ago, we came across a problem that a lot of users were leaving to the WhatsApp application. So we decided to write our own messenger, which will be instant, fast, and has a lot of features that new modern messengers have. So we started from just these two simple screens. It doesn't seem too complicated, right? What else can be here involved? So we started from this set of features, like real-time send delivery, and we took around 2 months to develop initial MVP. So we started from each real-time send delivery, one-on-one and one-to-many, and then add some image and file sendings, and after that we added some delivery statuses, and that was that typing, line status, pagination, offline send, delete chat, block list user, and different types of chats, search, chat with Lalafall, chat with bots, automated response, and list goes on. And we didn't expect that it will be so much features, and we definitely didn't account 2 months of those which we account wasn't enough to implement all of them. Our ideal was a Telegram application. It was fast, reliable, and secure. And we wanted to be at least as good, our messenger to be at least as good as a Telegram. But little we know that Telegram code base consists from 500,000 lines of code. So, as you may guess, not everyone has such many knowledge resources to build a system like this. So, because of that, a lot of different solutions come out to implement chat systems. We're starting from something as simple as writing everything on your own to full-fledged platforms for chats. And as you can see, there is many different options you can choose. There is open source protocols which you can choose and write on top of them your own system. And one of them is like WebSockets, long polling, and HTTP streaming, and other ones. Another one might be the open source transport, which is available already with some communities around this, like Socket.io. So there is already some wrappers around it. There is some backward supports with web platforms, for example, in the version of Socket.io. And we can go deeper and use infrastructure as a service and use a platform as a service. And with each this layer, you need to be less accountable of all those features like security, authorization, and other things, because those platforms will fix, but at the same time, it will give a lot less flexibility. So the question you need to ask yourself is how much time you have and how many resources you have already, like which types of developers already in your team, and what can you do with this. In this talk we will go through the first two part of the solutions, which is open source protocols and some frameworks, and the rest of it you can read more in depth on the websites. The main thing is that the more it goes on the right, the more functionality available, and like chat solution providers and SaaS like Zendesk, they already give provided UI for your chat, so you don't need to build any UI and Android app, and you can just put it inside and it will work. For example, we use Zendesk for gathering complaints in our application, and it might be good work for example, for something as simple as a website where there should be some online support, it might be enough to put our already established solution, and you don't need to invent something new here. All right. One of the crucial parts of the messenger application is transport. And there is many different ways to implement and onboard this. So we can start from something as simple as HTTP and the good old HTTP. So what are the problems? I need a volunteer here who can be a volunteer. All right. So imagine you being a general or captain, and I'm being your soldier. And every time I will ask you a question, do you have any orders for me? You will respond no. So, do you have any orders for me? Do you have any orders for me? Do you have any orders for me? So imagine if everybody in this audience will ask these guys, do you have any orders for me? And and how big of a waste it will be, because how much we will need to spend our resources on the backend for all these queries, and that might be a little bit over. Moreover, which problems we can have here is that's about a picture. It's simple. I mean, it's widely used. We already know how to use it. Every developer starting from training can implement this. But the problem is that the open connection on the mobile is expensive, and each time we doing requests, it's not that good. Another thing is many wasteful requests, as we see here, and it's slow. It's slow, it's not real time. It's not exactly what we want, but we was using this approach, I guess, around 2 or 3 years. So it was serving the basic need, but might be good for start, but then as you see, users started leaving to WhatsApp. So there is maybe another approach. It's kind of not very costly to implement. We can add on top of this Firebase Cloud Messaging, and whenever there will be new messages, the backend will notify through this Firebase Cloud Messaging all the devices, and we kind of get some kind of real time. So it's not really, or not always reliable if there is millions of messages sending across this Firebase Cloud Messages, because if you read closer, there is some restrictions on processing all those messages. And but still, it more or less better than just having HTTP. So what does pros is that it's close to real time. It's kind of emulation of bidirectional communication, so we can send some different kinds of push notifications on which we will do some kind of actions on the device, on client. So it will be like some random protocol, our own homemade. And the problem is that it's third-party service and has our own restriction, as I said, and it carries all previous HTTP downsides. So let's move on to another one. So another one is bidirectional transport. I'm not giving here any specific example, but rather the idea itself of how does it work. In this case, client will send messages, and chat microservice will also. And what is the main thing is that all these messages are going without any order. So this, in terms, this forces us to implement it in a little bit different ways than we used to implement our HTTP calls. So we need to structure our application differently, because all these messages are coming mixed from the chat microservice, and there is many pitfalls which we go closer to in a minute across this. So there is many messaging protocols. If you look on the Wikipedia page, it's more than 20, and on this table, hard to see, but they're split by different traits. Some of them are more secure, some other supports different kind of features like group message, and there are other ones. The idea here is probably to look closer and to understand your business needs, because there is no one bulletproof bidirectional transport which will work in any case. So in our case, we've chosen Socket.io, which uses in terms of WebSockets under the hood. And the It's kind of fast, it's bidirectional, it supports web, and this is like the main reason why we chosen it, because implementing WebSockets, it has its own cost, because it goes on top of HTTP, it goes a lot of this ceremony which we need to do to establish connection, and this takes some time. So if you don't don't need to support any web platform, and you're free to support mobile, you can go with something as low as TCP and use some protocols based on TCP only. So another benefits is that it do not use waste connection and resources. So we constantly listening for new messages, and the downsides that it has 200 issues for Android library, but I'd say that using it is not that necessary, because under the hood the library just uses socket HTTP with WebSocket factory. So I think everyone will be able, like experienced Android engineer will be able to get and fix anything if there is a problem. So we gave this prototype some time, because initially we didn't want to go with this, but like web team was pushing hard, so we decided to give it some time if there will be any problem on that. It turns out okay, and why we can say so, because we have like 20% Android 4 devices still, because we are based in many our main countries based in Asia, and that worked for us good so far. So let's go to some best practices on implementing the bidirectional transport. In many cases, if you start to implementing it, all these protocols will have similar issues, and they go from the problems that all messages comes not in an order as we used to in HTTP. So all these problems come from that, and from there we need to fix them. So the first one is send delivery receipt, and we can implement them using acknowledgement ID. So how does it work? For example, imagine you have this socket open between chat microservice and Android client, and when there is a new message coming from chat microservice, you will write acknowledgement, and chat microservice also will write acknowledgement. And this acknowledgement ID will in turn allow you to do certain types of actions. So you will know that when you send a message for some specific action, you will receive acknowledgement, and you can compare and then do something with this message. It also allows to provide send delivery receipts. So when there is acknowledgements and they equal, so the receipts can be like checkmarked appear. Okay. Another one is duplicating messages. So imagine that there is not only one client connected from one user, but there might be many devices from one user. There might be one tablet, one Android, another one, and even nowadays web clients. And what is happening here is that when we send in a new message from one client, this chat microservice need to notify all the clients about this message, and it will send back the same message. So to avoid this problem, we can use socket IDs and put socket ID in each message. So when there is a socket ID which are equal to our client, we just the backend will just ignore and don't send to the sorted ID any messages. It's about duplicating messages. Another issue which might be here is time sync and message order. So imagine that on one device there is one time zone, and on another device there is no time zone, but just some custom built time. Somebody set the time, and we need to show all messages according to the history. And there is might be like if there is a different time, they all be mixed. And when we will try to send new ones, there will be like this recycler is spinning all the time, because there is a time might be different. It might be at the beginning, but we want to prevent it to the end, and it will may cause some recycler view interesting bugs. So to avoid this issue, there is a couple of different approaches. The simplest one is to check all incoming messages on time, and if we want to send a new one, then we will send it at least as later as all received messages, and not before. And then later on the backend, these send messages will receive a proper timestamp, and all other clients will be notified. It's the simplest one. The more complicated but more like stable approach probably is to send time from the backend all the time about current time, and then store the diff on device, diff of this time, and according to this diff, sending new messages over this diff. So. This is about it. Another thing, so we went through some transport issues, but there is also some platform issues, platform related with all messenger applications. And one of them is battery concerns. So we have many low-level devices running Android 4 still. As I said, it's around 20%, so we wanted them to work as long as possible. So what we did is as simple as we don't listen to our socket, we disconnect it as far as user leaves the application. When it goes to the background or just exit, we will try to catch this lifecycle callbacks. It's not exactly how it works in our app, but I mean it's just like from the sample from the docs that you can use these listeners to connect and disconnect. And so, as I said, we don't keep connection open after user leaves the app. Another thing is some services will use for ground service for this purpose, and I mean it's also will be very battery draining thing, but of course it might be depends on the case, but pretty often we don't need it. Another thing is to rely on Firebase Cloud Messages to notify the app about new messages. So if the new one appeared, then we can start doing some connections. And if the user is still in the background, one thing we can do is we can prefetch the messages after Firebase Cloud Messaging notification with the work manager. And when the user will tap on it, there will be all new messages. Alright, this is about battery. Another thing is the startup time. So as you've seen, there is a lot of features in our Messenger application, and it's a big separate model in our app. And we don't want to provide all dependencies, build everything for the Messenger as fast as a user would start up the application. So what we use in many cases, we try to add a callback for the looper when everything will be ready and up and the first screen will be displayed. Then we will start to connect to our socket. So it's a good technique to use, and then we will provide all dependencies and start our socket connection. And it's a good technique to use not only for the messenger, but for many other heavy components in your application. So if you have something that shouldn't immediately start, but will need to be eventually at some point in time, you can put it here, and startup time will definitely improve with such thing. Okay, another one. So we went through some points on how to implement and choose the transport. So I'll try to recap them and go further. So the first one will be to determine your business needs and choose appropriate transport according to the time you have. Because if you don't have time, it's probably better to use some platform already which has a chat. And speed, of course, if you need the fastest market, and if you're trying to build new competitor of WhatsApp, you probably need something better than already existing platform. And security is another one, as well as features and web support or other platform support. And remember about Android, about battery and startup time, so those things are important at the end. So there is, as you've seen, there is many features in those two screens. So for they will work smoothly and the developers could implement them easily, we need some good foundation. And that foundation probably should be a little bit better than this, but still not worth it for some reason. What we wanted in our app, in this architecture, it would be extensible and composable. So we've seen a lot of features there, and we wanted to add them easily, and this is why we need these traits. And another thing, maintainable. So what I mean, all these features, they not only exist, but we also need, we do a lot of A/B tests with them. So we try to add something, and then we check the metrics, analytics. Is it more responses in this messenger, or how we can improve these responses? So we often do switch off and add some new features, and this requires it to be very flexible and maintainable, the architecture and foundation for the messenger. As well as reusable. Why? Because we do integrate this messenger in some other parts of our application, because there exists, it's like separate screens where a user can get and do some sending messages and other things, but it also exists on screens with items, with listings, where a user can send a message immediately. So we do want to reuse components which are existing in our chat system, and as well testable, because all those features are intertwined, they're fully packed. We want them to be able to test. So there is probably everyone familiar screen about clean architecture. So everybody knows it. It's there 10 years, I guess, even more probably. And we here didn't invent anything new. Just we already used it in many parts of our app. So we just went with this approach with some modifications. So in our app, it looks like this. I don't know if you can see it. So there is the yellow layer. It's like data and like data layer, so to speak, and driver layer. So what is here is UI. We try to abstract from all external things like UI, like sockets, like APIs, database, like deep links, Firebase cloud messaging. We try to abstract from all those things. So in case anything will break or suddenly Google decide like sunset another product, we will be able to replace it with something else. And the second layer here is the kind of like a presentation layer. So here we try to, we have these interfaces through which we communicate with these external dependencies, and we have the implementation, which those implementations are injected into concrete use cases. In our particular case, we call them operations. So for each feature in the app, we have chat operations, typing operations, unread counter operations, send message, block user, delete chat, and basically almost of any single case we try to separate and inject the implementation of each needed dependency in all these cases. So this works out well, and with things like database and APIs and sockets, it's pretty simple, right? You from database you just observe the data and do some transformations, and there is no big problems. At least we came across. But there are some issues around the presenter and abstraction from UI. From UI and from use cases, there is usually many different approaches right now. As you know, there is MVP, MVVM, and other ones. And this is happened not because everybody wanted to invent something, but because there was a problem. And the problem had to be solved somehow. In Android, it's very noticeable. So in our app, we used the MVP almost everywhere, except when we started to build some things like Messenger and some other feeds, which can change all the time. Depending on different events, because might be certain new socket event, there might be something from event bus, database changed, the user clicked on new link, and all those events, they changing what is displayed on screen. So initially we went with MVP, and I guess you all know this diagram, how this works, that we have a presenter, it's nothing new. And what happens is from the view might be click the button, and presenter we will trigger some action on model and then observe some changes and render the data. So as far as there is something simple on the screen, this is works fine. And but imagine if there is more things going on. Like if like one button clicked and then do something, then there is a new order events coming from all different areas, like tab change or blacklist event, or new chats appeared, or all the things will try to change what we should display on the UI, and it's hard to orchestrate all these events and display something meaningful, and there is like really big part of dependencies. Like, and you need to calculate all the combinations, and as you know, like complexity of combinations is pretty big. So, and imagine if we add the parent presenter with some more stuff, like account changes or language changes, and then we also need to do something about it. So, there is a guy in the Android community, I guess most of you know him, it's Hannes Dorfman, and he has written the post about this MVI and MVP approach. So all those things were resulting in something like this, like inconsistent, but it's simple, right? This one is simple, and imagine the app more complex, there will be a way better picture. So, and the problem with those bugs is that it's hard to catch them up, because it's not always QR can see them, and then there is no steps to reproduce, and it's really hard to find them after all. So we went with MVI. We had a state machine, our own built, like a couple of years ago for the old version of chat. But those state machine was pretty heavy and very opinionated, and we decided we need to refresh our existing implementation of something better. So we really like the implementation from Eric's Redux, which is also invented by Hannes Dorfman from Freeletics, and for this a big thanks for him. And we use that approach. So there is the problems which I went through, that there is many events can trigger send change, and as a result we can see a broken UI. It scales badly on huge complex screens, and the testability, like how we can test all those combinations in a presenter, it's pretty hard. And what happens after you add another combination of these all events? It's really hard to test it, because it's always breaking after a new combination of events. And we went with this MVP MVI approach. So what is happening here is that now we have in our presenter a state machine, which is responsible to orchestrating all those events. And now we have always the last version of state. And based on this, we can reduce the state and display a proper one. So in case here that you click presenter into selected, then we will trigger the action, item selected action here, and we will trigger side effect, which might update something in database, and at the same time trigger a reducer to update the state if it's necessary as a result of this action. And then there will be the calculation of new state, and here it will be already clear which state we need, because we had the old one, and with old state we can produce a new one which will be correct and forward it. Alright, here's this just a simple same screen, and here is the overview of this more simplified, I guess. This one more simplified version. You can use view model or presenter and just put inside of it the state machine, which is Eric's Redux, and all this action will produce some state. And it's important to notice that those actions might be not only the UI actions, but is all actions like events, account changes, language changes. These are all the actions, and which after visiting reducer will be a proper state. So there is a sample in this repository. We'll go just quickly through it. And here we have a set of actions like which are showed in this scenario. So what happened here, we just want to load the page from GitHub and implement some pagination. So there will be page loaded action, which will transform into state. At the end, there will be start loading at next page action, and there will be error, of course, and like load next page action. So those actions will be reduced to some of these states, and this is loading state, as you see, error state, and content state. This one is easy, I guess most of you are already familiar with this. And what happens next? We need to set up this. Here just called pagination state machine, but we can call it whatever. And the idea here is that all actions comes through this relay or subject, published subject in rich Java, and they all trigger changes in this state machine, which is regex store. And this regex store, we will give some initial state, what we should decide at display on the screen. We will give set of side effects to load new page and next page, and reducer function. And reducer function will be, in our case, is just loading next page. So here, what we are doing, we have a set of actions. We filter to appropriate one, which is loading as a page, and then with this page, we will produce a state. And in case of error, we will return error or loading or result. This I hope is clear. So here is a reducer. This is basically a reducer which reduces action to each. This is to each state. Okay. And display state. What we do here, we just orchestrate our views, but it would be nice to rebuild the whole UI with Compose in the future. I guess it will simplify a little bit the pattern itself, and as well as getting all those actions through the state machine. Okay, there is a couple of tricks here. As you know, this messenger, a lot of events can trigger change in recycler view at the end, because messages may change because of the new coming, and we want to avoid rendering the same state. And on mobile, performance matters, because it's close to us. And as a trick we can use, we can distinct all the changes which is already the same. We can go one level deeper and do it by some specific property instead, but as a sample, we can just use this one. And our learnings. As I said in the beginning, this project was planned to be executed in a couple of months, but took almost 9. And what I suggest is during estimates, do have a prototyping, do invite experts. Because we didn't invite experts in the beginning, we invited them a little bit later, and it really helped us. So we invited experts external from the industry to come over and figure out something. And it really did help. Do a proper grooming session as well, so we can gather all information required and do good estimates. So you won't end up in a situation like this. Another one is use appropriate technology for the task. There is many tools available to build a messenger right now, starting from big platforms and ending like implementing everything from scratch. Do understand the core needs of your business and choose the tool wisely. Another one I would suggest is design for flexibility, because as I said, the chats evolve a lot right now. There is like chatbots and many new features, and they all intertwine together, as I said, in those two screens. So designing for flexibility in this case is very important compared to other ones. And start small and validate hypothesis earlier. So we could validate our hypothesis with a Firebase Cloud solution maybe, but we didn't try to. So this was one of our mistakes, I guess. That might be not even needed anymore. Maybe you don't need the instant messenger with all the features. So the earlier you can validate, as you know, the less the cost of change. And that's about it, I guess. Thank you for coming.
Question? Does anyone has a question?
Was it good to understand the content of the talk? Or
So we'll close for now. Okay. Thank you so much, Andrii. Hands of applause again, and we'll.